tomorrow, your question on this will be very similar. Honestly, the only things that I would change would be, I might change what the solution is, I might change what the temperature is, or what the concentration range is. But it's going to give you something, cucumber, zucchini, sweet potato, whatever, and that you soaked them overnight in various solutions, exactly what we did in the lab. The percent change in mass was recorded from each solution, and then you're supposed to figure out which solution was which. Graph it, and then from your graph, determine C, and then the last thing it's going to ask you to do is solve ICRT for solute potential. Remember, I, R, and T, you'll have, what you have to get from your graph is C. So let's take a walkthrough of this. So first, figuring out how to put these in the proper order. So they're telling you they put cucumbers in various solutions overnight. I know that a cucumber cell, like any cell, has some solute in it. I don't know exactly what its molarity is. That's what I'm going to figure out from my data. But I do know that the most hypotonic possible solution I can get would be pure water, which is 0 molar. And I know that if I put a cell of any kind into pure water, what's going to happen to it? Well, eventually it would burst, but in this case, it's at least going to swell. Does that make sense? Because this is as hypotonic as I can get. Pure water is got no solute. So I know whichever one of these solutions is pure water should be the one that my cells gain the most weight. So which solution would that be? Right, letter F, which is the 5%. This has to be my pure water. This will always be your answer 100% of the time. When you're putting these in order, whichever one gains the most weight has to be the pure water. Now, my next solution, in this case, I'm doing 0.1, 0.2, 0.3, 0.4, and 0.5. That's the 5 molarities aside from the water. I know that if I put my cell, whatever it is, in 0.1, it's going to not gain as much weight as in pure water because I should be getting closer to whatever the molarity of the cell is. Technically, if I pick a molarity that's higher than what the cell is, it should lose weight. But in this case, my next number going from highest to lowest after 5 is 4%. Does everybody see that one? So that must be my 0.1 molar. In other words, it gained weight, but it gained less weight than it did in pure water, which makes sense. I must be getting closer to whatever the actual molarity of my, whatever this is, cucumbers would be.
And you get those values from when it tells you 0 to 0.5.
Yes, correct. Okay, so my next one, my 0.2 molar solution would be which one? 2%. The 2%, A. This has to be my 0.2 molar. Again, I'm just putting my numbers in order from highest to lowest. When I put it in this one, it gains even less. So I know, again, I'm getting close to whatever the molarity of my cell is, but I haven't hit it yet because my cell still gains weight. So whatever the molarity of my cell is, it must be higher than 0.2. When I go to my next number, I now am negative. The next number going in order from highest to lowest is -2. Aha, I have now gotten to 0.3, and in 0.3, it lost a little bit of weight. You know what that tells me? That tells me that the molarity of my cell must be somewhere between 0.2 and 0.3. That somewhere between here, I crossed the line, and I went from it being hypertonic to my cell now being hypotonic. My 0.4 would then be this one, and the one that lost the most weight would be my 0.5. So, how do you put them in order? Whichever one gains, you put them from the highest, gains the most weight, is going to be your 0 molar pure water, to whichever one loses the most weight is going to be your whatever the strongest molarity is. But you'll put them in order in increasing molarity. Now you graph it. Question.
So we always assume that one of them is water?
For the one I'm going to give you, yes. Yes. I mean, obviously, if you weren't given water as an option and the first thing you tested was 0.1, then this would be 0.1. Whatever your lowest molarity is, it's got to be the one that gained the most weight. But at least on the AP exam in the past, and what I'm going to give you, pure water, 0 molar pure water will be the one that gains the most weight. All right, now you're going to graph it. So how do you graph it? You make an x-axis here. You can actually make it at the bottom if you want to, but since we're looking for where it crosses the 0 line, I would put it in the middle. I'm going to put my molarities on my x. That is the independent variable. That's what we changed. So this is going to be my 0.2, 0.4. Oh, it's not 0.2. I'm sorry. 0.1, 0.2, 0.3. In the lab, it was by 2s. 0.4, 0.5. So this is a 1, 2. Okay. And 0 molar is right here at my intercept. So that's my molarities. My y-axis is my dependent variable, which is my percent change. So positive is going to go up here. 1, 2, 3, 4, 5. This is a little sloppy. Negative. I tried to come up with numbers on the test tomorrow as well that it'll fit on the graph without you having to try to get creative. You know, oh, I can make each one worth 2 or 5. I tried to make sure it was big enough that you could easily graph it quickly. All right, so now you're just going to plot your points. So very, very quickly, my 0 molar gained 5%, so that's going to be here. My 0.1 gained 4%. My 0.2 gained 2. My 0.3 lost 2. My 0.4 lost negative 5. Oops, sorry, here. And my 0.5 lost 7. I don't care if you make a line of best fit or you connect them. It does not matter to me. This was a 5. The important thing is that you determine where it crosses. This is where I think best estimate would be isotonic to my cucumbers. I know that they've gained weight in 0.2, they lost weight in 0.3, and I'm going to estimate for mine about 0.25, and that's C. That's what I think the actual molarity of the cucumbers was. Now, if your graph was slightly different, your C would be slightly different. But nobody's should be like over here. You know what I mean? I mean, there's a range of acceptability of where that line should fall. Okay, so last thing, question?
Do we just estimate that, or would that have to be an exact 0.254?
No, you're estimating it. Whatever seems logical. So I mean, I would accept anything from 0.21, 0.22, 0.28. But I mean, honestly, if you make a line of best fit, if yours ends up crossing exactly on 3 and you 0.3 and you put 0.3, I'll accept that. You know, like I said, it's really your best estimate of where you feel that it crosses, but it should match what you drew. Yes. The molarity at which you think would be isotonic to your cucumbers. Because in theory, it wouldn't gain or lose weight in that molarity. I mean, what we're basically saying is we think the cucumbers are 0.25. So if I repeated this experiment and I put my cucumbers in 0.25, my prediction is they wouldn't gain or lose. That it would be exactly isotonic.
So if the points don't have, the line does have to hit all the points, or doesn't?
It doesn't matter to me. You can try a line of estimate. Usually on the AP exam, they give you something that makes a beautiful, perfect line, so you don't have to worry about it. But for my test, I honestly made up numbers. So they may or may not make a very nice line. So you can either connect your dots or you can try to make a line of best fit. I don't care.
My line, just like I missed 2 dots, but like good lands on, I would want to say like 2.1.
So 0.21. Right? 0.21. Yes. So then that would be acceptable. It matches, your line matches your number. Correct. So based on my number, to wrap this up, negative ICRT. It says that the solute was sodium chloride NaCl, so what's I? I is 2. C is where it crossed. So for mine, that's 0.25. But like Isabella got 0.21. That's not wrong. That's what she got from her line. That's fine. 0.0831. That's your constant. That's on the formula sheet. And what do you need to do to the temperature? Perfect. Change it to Kelvin. So this is going to end up being 298. For mine, when I plug all of that in, I got negative 12.4 bars. Remember, your units are always bars. If you can't remember what the units are supposed to be, you could always plug in all the units in the formula, and they'll all cancel beautifully and give you bars. But if you can just remember that bars is the unit, just put bars in your answer. I'm not going to grade you on whether you put your units in the formula or not. Don't forget negative. Again, on the lab, biggest mistake. People forgot negative. People forgot bars. Yes. Okay, so I is what's called the ionization constant. So it's how many ions something breaks into. The formula sheet specifically says that if it's glucose Actually, I think the formula sheet only says sucrose. They're not ionic. Okay, so if it's sucrose, that's not ionic, I is 1. If it's an ionic thing, which is pretty much any formula, you literally count how many elements or how many atoms are in the formula. Like, so if it was this, just so you can see, this would be 3. 2 chlorines and a calcium. So that's how you get I.
Say if it is glucose or sucrose, would you tell us I is 1 or no?
No, I wouldn't tell you that, but it says it literally. It says here, ionization constant. This is 1.0 for sucrose because sucrose does not ionize in water. So they tell you that. They don't say glucose, but I'm telling you, glucose, sugar, sucrose are all sugars. They would all be 1. But they do tell you sucrose is 1.
On the AP bio test, are they gonna do the not the equation, but for glucose? Would they not write it out?
I mean, this is the exact sheet they give you on the AP exam.
Oh.
This is the formula sheet from the College Board. So you would have this in front of you. Most likely on the AP exam, they would give you sucrose. They probably wouldn't even have you try to figure out how many ions were in an ionic thing, quite honestly. I taught it just in case, but usually they give you sucrose anyway. Anyway, that's it. That's the whole shebang. That's exactly what you have to be able to do tomorrow. You actually will not have to calculate water potential. Water potential, remember, is actually just this plus pressure. But again, usually on the AP exam, they tell you that it's like an open container and that count pressure is 0. In which case, these are equal to each other. So I didn't make you calculate this, but in theory, if you can get this, getting to that is like cake. So I'm not worried about it. No calculating water potential, nothing. This is literally it.